Welcome, students. Today we're going to talk about circles. Specifically, we're going to be looking at the graphs and equations of circles. Now, I like to ask my students, what's the definition of a circle? And sometimes there's silence. Usually a student will venture that it's a shape that's round, but there are lots of shapes that are round, not just a circle, but an oval and other things like that. And then usually there's at least one student who starts talking about radius and circumference and things like that. And then we start to get closer to the actual definition. But let me give you the mathematical definition of a circle. A circle is the set of points a given distance, the radius, away from a given point, the center. The whole point of a circle is that this distance is constant, and now that we know the distance formula, we can represent this algebraically. What we're going to do is we're going to draw a generic circle, and then we're going to use that to figure out what sort of an equation is going to give us a circle for a graph. So I'm going to draw a very generic XY plane. And I'm going to draw a circle. Not too bad for a hand-drawn circle. Now, let's say that the center of the circle has coordinates h and k. That might seem weird, but we want a way to label them, and mathematicians wanted a way to refer to this important point using letters that weren't usually used in other situations. We know that x and y are usually variables, and a, b, and c are sometimes coefficients, and so they picked two letters, h and k, that aren't typically used to represent other things. And then let's say that a generic point on the circle has coordinates x and y, and we know that the radius is r. Well, the definition of a circle is that any one of these points on the circle is a distance r away from the center, h comma k, and we can actually use that and the distance formula to come up with an equation for this circle. So for the distance formula, we know that the distance is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. We know that this is the formula for the distance between 2 points. What we can do here is we can actually plug in the coordinates and the distance, and then that will give us an equation in terms of the variables that we have here. So underneath the first parentheses, it's the difference in the x coordinates, and the x coordinates here are x and h, so that's going to be x minus h squared plus, then we need the difference of the y coordinates, that's going to be y minus k squared, and that equals the distance, but in this case the distance is the radius r. So this is the equation that we get by applying the distance formula and the fact that these 2 points are a distance of r away. And we're going to do one more thing. We're going to square both sides of this equation to get rid of that square root. If we do that, that leaves us with x minus h squared plus y minus k squared equals r squared. And this is the standard form of the equation of a circle with center given by h comma k and radius r. So anytime we have an equation that's in this form, x minus a number squared plus y minus a number squared equals the radius squared, which is just going to be some number, this is going to end up giving us the graph of a circle. What we're going to do now is go through two examples so we can see just how this works. So let's start with our first one. Let's sketch a graph of the equation x minus 2 squared plus y minus 1 squared equals 25. Now we're going to need an xy plane, so let's grab one of those. And let's make our circle. Now this does fit the standard form for a circle. We've got x minus a number squared plus y minus a number squared equals 25, which is 5 squared. So this is going to be a circle. What we need to do now is figure out the center and the radius. So h is the number that's being subtracted from x. In this case, the number that's being subtracted from x is 2. So h is equal to 2. K is the number that's being subtracted from y. In this case, 1 is being subtracted from y. So k is equal to 1. And so in this case, the center is going to have coordinates 2, 1, which is going to be right here. We can figure out the center of the circle just by looking at the equation to get the coordinates. Now, the constant term on the right-hand side represents r squared. So if 25 is r squared, to get r, we have to take the square root, and the square root of 25 is 5. So we know that the radius is 5. So we have to draw a circle that has this point as the center, and it has a radius of 5. You're probably not going to do an amazing job if you just try to do this by hand. I certainly wouldn't, even though I've been doing this for years and years and years. So I'm going to give you a little bit of advice on how to draw a nice circle. We know that this is the center, and we know that the radius is 5. That means that if we go to the right 5 points, this is going to be one of the points on our graph. Similarly, if we go up 5 points from the center, that's also going to be a point that's on our graph. And the same is true if we go left 5 points and down 5 points from the center. I like to plot these 4 points because that gives me a bit of a guideline as far as trying to draw my circle. Now my circle certainly is not perfect, and I don't expect if you're drawing circles that yours are perfect, but we want to make sure that you can tell that you tried to draw a circle. If you draw a diamond shape, that's not going to cut it, right? We want to make sure that it's smooth all the way around, there's no corners, it goes through those points, and then this is our circle, x minus 2 squared plus y minus 1 squared equals 25. All right, let's do another one. This one's going to be just a little bit different. This time we need to sketch a graph of x minus 5 squared plus y plus 2 squared equals 5. Now we will grab our xy plane for this one. And we are ready to figure out the coordinates for the center and then the radius of our circle. Remember that the x coordinate of the center comes from the number that's being subtracted from x. In this case, that's 5. So our x coordinate is going to end up being 5. Now, for the y coordinate of the center, it's the number that's being subtracted from y. But in this case, we have a number that's being added to y. Now, that's not actually a problem because we can write an addition as a subtraction. Adding 2 is the same as subtracting what number? -2. So in this case, the y coordinate of the center is going to be -2. If ever we have a y plus something instead of a minus something, or an x plus something instead of a minus something, that coordinate is going to end up being negative. Another way to think about this is that the coordinates of the center are the opposites of the constant terms inside the parentheses here. The constant term here is -5, so the x-coordinate is +5. The constant term here is +2, so the y-coordinate is -2. So we've got our center at 5, -2. We can plot that right there. And then for the radius, some of you might be thinking that the radius is 5, but we have to be very careful. This 5 represents r squared. This is the radius squared. So if we want to figure out what the radius is, we have to take the square root, and the square root of 5 is going to be √5. Now, I am going to use a calculator to get an approximation for this. That's about 2.2. And the reason is, if we're going to make a radius √5, we actually need to know how far away that's going to be realistically. And getting a decimal approximation helps. So the radius is 2.2. So from our center point, we need to go about 2.2 units to the right. It's going to be about right there. 2.2 units above, 2.2 units to the left, and 2.2 units below. And once we have those points, we can go ahead and draw our circle. And this is the graph of x minus 5 squared plus y plus 2 squared equals 5. Definitely make sure to look at the examples that are linked below so that you can get some more practice with this.